So we'll go ahead and get started. My name is Ryan Harter. I'm come all the way from Chicago. I'm a freelance Android developer, so I work with a lot of really cool clients. I'm also a Google developer expert, and I've got a few apps of my own that I want to talk to you about today. In my freelancing, I work with a lot of clients, and so that gives me the opportunity to see a lot of different companies' approach to different things. One of the things, particularly in consulting, that seems to be kind of the holy grail is reusable code, right? The idea that even if it's not open source or not public, if we can make reusable code, we can be more efficient, faster, higher profit margins, blah, blah, blah. Everybody knows the story. A lot of companies try this. A lot of companies do surprisingly poor jobs of this. Some do really well, some do not as well. But in working with all of these customers and my own projects, there's some things I've learned along the way that I'd like to share with you. So by way of introduction of what we're going to be talking about, here are two of my apps. Wow, color is terrible on this. If you can see, they kind of have black backgrounds, so it's hard to see. But Fragment and Shift, these are both photo editing apps, and the way that this relates really well is these are photo editing apps that kind of take different approaches. Fragment, you can kind of see sort of this thing in the middle here. You overlay these fragments on your photos, so it's sort of it's more about creating art than it is about, adding sepia tones to your photos for Instagram and that kind of stuff. Whereas Shift is more of the sepia tones, light leaks, textures, that kind of stuff. So more of a mainstream type of things. Both of these apps have very similar portions and very different portions. The editing is all different. The meat of the rendering is different for both of these, but they also have the similarities of you have to be able to load images from anywhere. The OpenGL rendering core of this, like at its basic, it needs to display an image, right? So that's shared stuff. Exporting, like a lot of this stuff is very similar between these two. When I developed these, I developed Fragment. I started in January of last year, launched it in August. So it was about 7 or 8 months of development. Shift launched on Christmas last year, and it took about 2 months. All right, and in large part that was due to the fact that I was able to share probably 50 to 60% of the code of these apps. So these are the main editing screens, some other parts that are shared. The inspiration section where you can see what other people have done with these apps. You can see they're styled differently, but very similar. And here's the export screen, which has some differences, which we'll talk about later. And these kind of apply to different strategies of how to make your reusable code. So to give you kind of a high-level overview, here's what I'm going to talk about. This is kind of more of like a cultural attitude towards reusable code and how to make it work. There are some technical strategies we'll go over. But we'll dive right in. I'll be going over each of those bullets in detail, so we don't really need to cover that very much. So the first step to really making reusable libraries that work is to identify good candidates for reuse. This seemingly simple step is oftentimes overlooked. I've worked with a lot of people who make custom edit text so that they can validate certain things where the system already provides that, or they make their own implementation of different things. But it's really important to identify good candidates for reuse. And so the first thing that I like to think about of a good candidate for reuse is where it's going to be used, right? If something if you don't have a plan of where you're going to reuse something, it doesn't need to be reusable. Particularly in consulting, where we sell custom development, if something's only going to be used one place, then it doesn't need to be reused. With Fragment, when I developed that, Shift wasn't even an idea at that point, so that was all custom, right? It helps that I was learning OpenGL at the time, so there was a lot of stuff I did poorly, but outside of that, that was all custom development because I didn't have another place to use it. So it's kind of a time waster if you spend your time trying to package things, make things reusable without a plan for where to. The next step is to not reinvent the wheel. There's a lot of stuff out there, particularly after Google switched to Gradle, and dependencies are really easy to get a hold of. Android has a really good open source community. There's a lot of packages out there like Retrofit and Picasso that just make things a lot easier, and it's not worth your time to try to reinvent these things. When thinking about reusable code, I really like to think of two categories of libraries. You have your utility libraries, which are non-user facing things like Retrofit. They're developer-friendly libraries to make your development life easier. And then there's UI libraries, as I like to call them. And these, I think, are purely anecdotally a little bit less prevalent. And I think there's a little bit more care that needs to be taken with these because this faces your user, so it's important that you're not encroaching on people's branding and that kind of stuff if you're going to share it between apps. And we'll talk about that in a minute. So I went through how to speed through that. Just an idea of really how to identify good candidates for libraries when you're looking at open source libraries. I think Jake and Jesse covered this pretty well in the keynote yesterday. But the big thing is just go take a look at what's out there. That's really important. When we get to other apps, you look at like Google Apps, maybe Inbox, you look at that and you see like, oh, I really like these features, I wonder how they accomplish this. With a lot of apps, you can go into the settings or the help and look at the open source licenses. Not all apps present that stuff, all apps should. But it's really easy to see even what Google is using. They use a lot of open source licenses, open source projects in their apps. And the last piece just to touch on quickly here is it's important to be confident in whatever open source stuff you're going to use. There's a lot of really good stuff out there, and there's a lot more really bad stuff out there. So the real simple high-level way that I like to do that is to count stars on GitHub. Assuming you're on GitHub, the library you're considering, just count the stars, see if people are talking about it. Jake and Jesse also mentioned check Stack Overflow, make sure there's a community, that's great stuff. And with open source, of course, inspect the source. That's something that I always do when I'm considering a new open source library. And these libraries are there to save us time, so in my opinion, it's not imperative that you understand the nitty-gritty of every single thing that a library is doing. You should definitely understand it at a high level, what it's doing and sort of the approach that it's taking to get there. But you don't need to necessarily know how it covers every single edge case. But what this can do, if you think about this like an interview, like when you interview someone, you have a whiteboard, kind of a sniff test, right? If the library you're looking at has a poor architecture or some poor choices that were made, that's probably indicative of a deeper problem, right, that you'll run into later. So it's really important to be confident in the libraries you use. So that covers identifying good candidates. The next step is to limit the scope and requirements of libraries. Again, a very obvious thing. If we think about the apps that we write, if you're writing apps for clients or for the company that you work for, most people will have a project manager or a product owner that is going to limit the scope and requirements so that they can avoid things like feature creep. And with libraries, it's important to do the same thing, right? A lot of companies I worked with have kind of thought of reusable code as the thing you write for this client, and then it's magically available for everything else, but that's really not the case. So what I like to tell clients and practice is that it's important to choose a single problem to solve in your library and stick to that. Jake and Jesse touched on that a bit yesterday, and that's really good stuff. If we think about that in practice, think about like the libraries that you use. They can oftentimes seem very complex, but you have to remember where these things started. So Picasso, for instance, Picasso is an efficient image loading and caching library, right? That's the one thing it does. It doesn't do everything else. It has some other features like transformations and that kind of stuff, but at its core, it's about efficient image loading and caching. Retrofit, another one, is easy REST API access. That's what it exists to do, right? If you saw the HTTP talk yesterday, you know, I think somebody asked if retrofit does caching, and the answer was no. That's not retrofit's job. That's the job of the HTTP library you're using. And that's something that's really important when you're working on libraries, so that they don't become bloated and cumbersome, is to really focus on the thing that your library is going to do, and make sure that everything you put in that library really accomplishes that goal. If it doesn't work towards accomplishing that goal, it doesn't belong in your library. One thing to be said here, which I think seems to be less of an issue than it used to be, is to avoid Apache syndrome. If anybody worked like in the J2EE days in Java, you'd use Apache libraries, and the problem was that every Apache library depends on every other Apache library. And at the time, I think that's less of an issue these days, but that was a real problem because now you have a lot of bloat, first of all, because if you import one Apache thing, then you've got all of this other stuff in your project, and they didn't even have DEX limits back then. But you know, that can be an issue if you've got your libraries that just rely on everything else. You're bloating the user's apps, and basically you have a monolithic thing at that point, which isn't super helpful. So speaking to this, it's I like to think of it as a mission statement, right? Companies have mission statements, which is hopefully a brief statement of why that company exists, right? What do you exist to do? Well, the same goes for libraries. In my opinion, it should be like one sentence that explains what the library does. You should be able to tell someone in a single sentence what a library does. An example from some of the fragment and shift work that I've done is an image loading library that allows users to load an image from any source. This is a seemingly simple statement, and it's a deceptively complex problem, right? Particularly on Android, you know, we've got really cool stuff like the document provider and that kind of stuff, which is nice. But the challenge there is that if you use the document provider and you get an image record back, it could be coming from a content provider, or it could just be a URL to something on the web. It could be coming from the photo gallery on the device. It could be a file stored randomly somewhere else on the device. Or, you know, in this case, we need to let users load images from anywhere. That could be a stream coming from the camera, right? So this simple sentence explains very simply and concisely what the library needs to do, but that covers a lot of complexity. And we'll get into a little bit more of that in a little bit. The next step, and this is my favorite, is to design a good API. Right? The value of a library is that people use it and people reuse it, and it makes your life easier. If it doesn't have a good API, none of that is true. So the first thing when you're designing an API is you need to think about who you're designing for. When you develop an app, you know, a lot of times you start out or think about the UX of the app, right? That's the API of the app, okay? That's, you know, how are the users going to interact with it and use this tool or game or whatever it might be that you're creating? Well, with libraries, the API is your UX. So you need to think about how are your users, which are developers in this case, going to be interacting with this. One of the things that I've seen in a lot of reusable code in company is this idea that, you know, here's the code, copy this into your thing. Well, in my opinion, if a user needs to mess with the code of your library, that's not a library, that's sample code. There's some big video streaming companies that their SDKs are really just sample code that you include in your app. But it's really important to have a good separation of app code and library code. One of the things that I like to do when I'm designing APIs for a library to not only make it a good API, but make sure that there's good separation of app code and library code, is to design from the outside in. And by that, what I mean is I like to design an interface first, right? It's easy to think, you know, when you have a problem of how you're going to solve that problem, but before I do any implementation, I like to design the interface. And then, on top of that, then I usually test it with a mocked out implementation. Okay, so I design the API and then I actually consume that API, that library in my app. And that allows me to make sure that there aren't any parts that I missed, that there isn't any data, you know, that I might have overlooked, while still keeping the focus on not the implementation details, but on the API and how users are going to interact with that. The last step, which seems really obvious but is overlooked by many companies, is to package your library. This has gotten much easier since the switch to Gradle, or if you were using Maven before. But you know, having some source code in a wiki somewhere is not a library. That's not a packaging mechanism. You know, how do you get the latest version, or make sure that all of your apps are on the latest version? How do you submit feedback or pull requests, that kind of thing. So it's really important to package your library and enforce a versioned release cycle. It's relatively easy to set up a Maven repository, an internal Maven repository if we're talking about internal libraries. If we're talking about open source stuff, send it up to Maven Central. Easy. So now I'd like to get into talking about these APIs a little bit and different strategies for APIs. And this kind of ties into the different types of libraries that you might need to create. So we'll start out with a utility library. This one is straight out of Shift. Okay, I have a history manager which supports undo, right? Undo and redo. At its barest, it's a stack, right? The idea that, you know, you push things to the stack, when you undo, you pop them off. But when you add in redo support, it gets a little bit more complex. This is a very simple case, but you know, the user can undo 3 times. They might redo once, and you still have 2 things that they can redo. But if they make a change, those are lost. Now you're in a new path. So the way that I start this out is by designing exactly this. You can see it says class up there, but this is obviously really an interface. At this point, it will be a class at some point. But this is what allows me to really look at the heart of what this does at its most simplistic and how it's going to work, okay? And then, as I mentioned before, what I do is change that to interface so it'll compile, and then implement a mocked version of this in test and actually consume this in Shift so that I know, you know, maybe there's some sort of edge case, you know, that I forgot. I think initially when I did this, I actually didn't include clear and didn't think of the fact that when you load a new photo, we need to clear the history so that you can do that. So that's a really good way to just make sure that you've covered all of your cases, and then and only then go into actually implementing this. This works really well for utility classes, but when we're talking about UI classes, something that needs to present a UI, there are some different approaches. One of them that I like to call the superclass approach. This is the washed out export screen in both Fragment and Shift. You can see they're very similar, and you might think that is just, you know, a launch intent for the same activity here, but there are some subtle differences here that involve custom business logic. For instance, if you notice the title refragment and reshift, we have kind of a special flow. If you fragment and you want to add a new fragment onto your photo, you send it back through. We call that a refragment. It's just part of our vernacular within the app, and so we need to be able to change labels based on package name. Shift is a free app that has paid upgrades, And here you can see the upsell to remove ads. But there's some custom business logic in there whereby if the user doesn't have Fragment installed, that might show a Fragment upsell. If the user does have Fragment installed, that's going to show the in-app purchase to remove ads. So the special case here and the thing to take away is that this is all stuff that involves custom business logic, okay? And so the way that I solve this approach is using superclasses or base classes. So if we look here, here's the base export activity, and this is just a snippet of it. The API for this, if you think of it that way, is through the protected methods, or public if you want. But basically anything that's going to require custom business logic, make those methods protected, and then you can override them in your subclasses. Things like getting the preferred packages. Maybe users of Shift are really into sharing their photos on Google+, but on Fragment they use Instagram. You know, something like that. That can be completely different for different apps. Getting a save folder. Here you can see an example. We have sane defaults where we can. In this case, you get a picture folder and a PicSite subdirectory. PicSite's the company name. Each of these apps are gonna override that to either have a Fragment subdirectory or Shift subdirectory to save all of your fragments and shifts to. In some cases, there aren't sane defaults, right? Update app info. This is what actually renames the icon to reshift or refragment. It might change the icon if need be. There's no sane default for that, right? Because we don't know, in the library what the app is going to be called, what needs to be done, what needs to be massaged. So that's just empty, and subclasses will override that. Subclassing is really powerful if you've ever used action bar activity or fragment activity or Sherlock activity, anything like that. You've used subclassing as an API to a library. It's one of the things that I think is useful, but also can be very dangerous. And the reason there is Java's single inheritance limitation. A class can only inherit from one superclass, right? So if anybody is going to inherit from your superclass for your library, that means that they can no longer use any other superclass style library, right? So that's the challenge there. It can be limiting. In this case, you can see base export activity extends activity, but what if that needs to be action bar activity or fragment activity or something like that? That's kind of the challenge there. You don't really want to have to build 16 of these for each variant of activity. Another approach is what I like to call the isolated activity. And with an isolated activity, we're using an intent as our API. Okay. In this case, this is the inspiration screen of Fragment and Shift. You can see they look very similar. They work very similarly. They're both loading Instagram feeds, filtering out certain content, and they've got options to follow the app on Instagram. And these two look very similar. They work very similarly. So they actually share an activity. To give you an idea of the API for that inspiration library, this is it. It's purely through the intent. I don't care what happens once that activity launches. I don't care if the user follows me on Instagram. I don't care if they, go look at, 5 images or 10. So in this case, the way to really identify the opportunity for this type of really isolated reuse is that everything that's custom to these, the business logic of how these function is all properties, right? You can see we just set the user ID access token skip tag, which allows us to skip promotional stuff, and the username when they click follow. And that's it. We load that from the activity. But you might say, Ryan, those look so different. How'd that work? This is something where I think a lot of UI libraries that are out there kind of overlook. Android has really good support for styling and theming. So in this case, the look of the inspiration section is all defined in the theme. So all of the customizable parts of that are predefined, and I just set theme properties set the styles in the theme to restyle it. And this is all of the code to integrate the inspiration into any app I write. The last, strategy, I guess, is like a hybrid approach. In this example, again, really hard to see. But this is what happens when you hit add a new photo. It pops up a dialog that says take a photo or choose a photo. This is that image loading library we were talking about before, right? What I've done is you can think of it as a utility library. It needs to handle threading so that it can download images if needed or load them off the file system, whatever. But the API for this is purely through the interface. I don't care about any of that. If I want to use it, I can. It has a Java interface that it exposes, but I can also just send this activity. It's going to pop up the dialog to help the user pick where they want to get their photo from. But at the end of the day, we use start activity for result, so we get data back. But this is kind of an example of it's sort of a utility library, but we're using the intent as the interface for it, which offers some really nice separation. So moving on from the strategies, another thing that I mentioned before was distribution. This depends on what you're doing. If your app is open source, Maven Central or JCenter, really easy ways to, good ways to distribute your libraries. Private Maven repos aren't all that difficult to set up. There's a lot of Sonatype Nexus or Artifactory repositories that you can get from JFrog. Those are pretty simple for private internal stuff. I got some slides on here for Git repositories. In my case, I don't want to host my own server. I'm a team of one developer and a couple designers and iOS developers. So I don't want to manage my own server because I hate that. I don't want to manage users, that kind of stuff. So for our private repositories, we use a Git repository. And the way that we do that is with some Gradle plugins that I'll talk about. But basically, Maven repository is just a file system. You can use an FTP server if you want, SFTP, SSH, whatever. You can also use Git, and the way that we do that, I've got a library that I wrote. It's super early stage, but it allows you to upload to a Git repository. So when you include this plugin in your Gradle build file, all you have to do is set the URLs to be Git SSH URLs, and that'll take care of deploying to your Git repositories. The nice thing about this is that Git already manages all of your access control and stuff. I found that I use Google Apps for Business and that kind of stuff, and Sonatype Nexus doesn't really integrate with that very well, as far as I've seen, as far as access control. So you've already got that on Git, so you can use that as your repository. I will mention though, for the most part, this is going to be useless right now. As of Gradle 2.2, I think, there were some breaking changes that affected authentication, so it doesn't really work with GitHub. I've got a PR out, and I'm working with Gradleware on fixing that, and it should. We're hoping that it's going to be in the 2.5 release, but that'll allow you to just use GitHub's raw URLs to get authenticated access to private repos. If you have a public repo for your internal stuff, if that makes sense, this still works. If you have open source stuff, don't use a custom repository, because then everybody has to add it to their POM. It's a pain. POM? Build.gradle file. Just use Maven Central. I believe the last big topic that I want to discuss is documenting and communicating. This is a big thing. Developing a library isn't just about developing the library. A library is not useful unless it's reused, and you need to document and communicate how to do that. So again, we get that, is it really a library if it's only used once? And what I think that a lot of companies, when they use internal libraries and that kind of stuff, kind of overlook is the idea that it's really important to communicate outside of engineering. This isn't just an engineering problem, right? I'm kind of in the consulting space, right? That's not kind of, that's what I do. But so for me, it's not just an engineering problem. What you know, libraries, a company I'm working with has available and what their limitations are, it's a sales problem. They need to know what to sell, right? If they go out to a customer and say, hey, we've got this whiz-bang library that does all of this, it's gonna be great, but then they promise all of this extra stuff that it doesn't do, well, that's just custom development. And your piles of gold from your inflated profit margins are now gone, right? I've never seen a pile of gold, by the way. It's also a problem in design, right? Particularly for UI stuff. You know, say you've got like a custom like TV schedule widget or view that you do, right? It's a type of recycler view, but it's a giant pain to work with. The way that those are laid out. If you've got something like that, design needs to know what the limitations of that are, right? If I add all this extra, you know, funky stuff in it, then it's, again, just custom development, and now you've lost your magical profit margins. So it's really important to communicate this stuff outside of engineering to everyone in your company. That can somehow be a cultural thing. I like to think of JavaDoc as really good for communicating to engineering. When I write the interface, when I first start something, I JavaDoc it. Not because, you know, everybody else needs to know exactly how it works, but because in 6 months when I come back to it, I'm not going to remember. And something like a wiki for internal company libraries, that's really good for outside of that. And I lied, the last piece, which is huge, is to manage the project. We do this with, you know, with normal apps that we write, and particularly in consulting. It's really important to treat your internal libraries just like you would a client project, okay? They have deliverables, they have requirements, they have all of that. As part of that, it's really important to dedicate resources, okay? So many consultancies that I've worked with have said, we're gonna write this for this client, right? And then all magic, reuse it everywhere. That doesn't work. You need to maintain your libraries, you need to fix bugs, you need a champion or an owner of that to be able to figure out how it's gonna work. Manage requests, feature requests. I think Jake mentioned something yesterday about, you know, you need to be able to tell people no. You know, this library, yeah, if it did this, it would be helpful for you, but not for everyone. That doesn't work. You need to define the requirements. We talked about that mission statement for the library, right? That's another really important piece. And this has been overlooked in most companies that I've worked with. It's really important to enforce a versioned release cycle. If you're doing open source stuff, this makes a lot of sense because you need people to know what the latest stuff. For internal stuff, this also makes a lot of sense. One company I worked with worked entirely off snapshots. That's useless, you know? The snapshot updates and now breaks all of your stuff, right? Version stuff so that you can deprecate stuff. So that you can be guaranteed that as long as I'm using this version, it's going to work the way I expect it to. If you have an internal Maven repository, that kind of handles this for you, which is really nice. And with that, that is the end of my talk. So, time for questions? Yeah, okay. So, does anybody have any questions about reusable libraries? Yeah.
I guess just touching on your point about like internal documentation, especially for engineers, for like say internal library you don't think it's going to be open source or anything like that. Quite often engineers just go and like look at code, and you say you sort of JavaDoc everything. Do you actually like post that JavaDoc somewhere and like host it on the product URL, or do you just say, hey, just build the JavaDoc and view it yourself?
Yeah.
So like at that stage right now, or like, I don't know if it's going to be really useful internally.
Okay, yeah. So the question is for internal projects, when you use JavaDoc as your documentation for engineers, do you post that somewhere? It's been different based on the needs. Like making HTML out of your JavaDoc is super easy if anyone's done that. So with some companies I've worked with, we've had just a website that gets deployed and the JavaDoc is available for that. My personal view is that like the source is super useful to have, but the reason that I really like the JavaDoc is not as much for a really deep understanding of what's going on. If I want that, I'll go look at the source. But so that when I'm working in the IDE, and particularly with Maven, if you have your source jar or your Javadoc jars, the IDE will present that information, right? So I'm going to use this method, and you can just kind of get a quick glance of verification that it's doing what you expect. So it's kind of been a bit of both. Any other questions? Yeah.
When you want to clone an application to make a new one, like fragment and shift, how do you handle the share code, and how do you handle the case that it's no longer share code?
Okay, so the question is when you, like with fragment and shift, I mentioned before that I developed fragment first and then shift kind of diverged. So the question is when you do that kind of fork, how do you manage the fact that a lot of the shared code is no longer shared? And the answer is you make it shared. The way that I did that, as I said, when I developed fragment, I was learning OpenGL. That was my first OpenGL app. So there was a lot of stuff that needed refactoring and that kind of stuff. But basically, when I started Shift and figured out what the requirements were and all of that, I actually went and sort of did an audit of Fragment to see what pieces can be reusable and what can't. And I spent, I don't know, maybe a week or two just pulling out code and refactoring it into packaged libraries, so AARs, but just kind of like deciding the architecture. The core of the OpenGL engine is going to be reusable between the two. Here's the parts that are. And so I actually like refactored that out into a separate module in sort of an implementation detail. But in Android Studio, it's super easy to just make new modules, right, that are part of your packaged compile or part of your project and compiled with it, so you don't have to worry about install to your local Maven instance and then update your snapshots here. So the idea is basically just to identify what you need to pull out and actually pull it out. A lot of companies I've worked with have used Git submodules for this type of stuff, and people like them, people hate them, I hate them. It's really hard to do versioning with submodules, and Gradle and Maven make it easy enough to deploy it. So, sort of by long way of answering your question, that shared code that's now these two apps that have diverged, that shared code is shared. It's a library in my private Maven repository. So when I need to make changes to the inspiration section of the app, I actually go make those changes in that library. And then when I update the apps, they get them. Other questions? Yeah.
I have a few libraries that I made myself, and I had my main app, and they're in separate Git repositories. I want to know how do you label all that so that I know this version of my application uses this version of my libraries.
Okay, so the question is, you've got multiple libraries and multiple applications, and how do you keep track, sort of what uses what version?
Yeah.
Is that? Maven. You use Gradle. And so the way that, like, my development flow, I guess, is that when I'm working on one of the libraries that I use, the internal libraries, I figure out, like, the requirements of the change, actually make snapshot releases and then update the dependencies. Once I know that it's working right, I'll actually cut a release at that version. And now, like, it's not Git's job to keep track of the version dependencies, right? That's Maven's job. So your Maven repository will store all of those old versions, and your build.gradle file will have the appropriately versioned dependencies in there.
I haven't actually dealt with like uploading to Maven or versioning with it, but how does like say you have potentially, I'm not sure, but potentially I'm guessing you have versioning on Maven versus Git, like using Git tags or something. Do you try and use Git tags to sort of be able to like just check out a version of the source that is like uploaded to Maven?
Yeah. So the question is how to reconcile the versions between Git and Maven. And exactly that. I use, in my flow, I use Git flow, which if you don't know Git flow, check it out. It's great. But it's just sort of a methodology of using Git that allows you to really version stuff with tags. So in part of my release cycle, when I upload a release to my internal Maven repository, that actually creates a tag in Git. So now if I need to do a bug fix for that version, I can go do that.
Is that handled with your Gradle plugin?
It's not handled with my plugin, no. That's something that that's actually so you can find more about me on Twitter or Google Plus or my blog ryanharter.com. There's an old article on there from a couple years ago, back when Google kind of said, hey, we're using Gradle, that talks about automatic versioning with Git, and it kind of goes over that. You can just put a function in your Gradle file if you want, and it will automatically it can automatically tag stuff or read the tags for the version info. But again, my plugin doesn't do that because that doesn't fit the core of what my plugin wants to do. Yeah, that just uploads and pushes to your Git repository. Any other questions? All right, I guess not. Well, thank you, everyone.